named constants. So constants, that's not how you spell it. Constants are also called literals. And they are fixed values that the program may not alter. We've seen a couple examples of these so far, and those would be integers, floating points, ASCII values, Boolean values, and strings. So something like like 1. You wouldn't necessarily call this a constant. I guess you could because it is constant. You can't say like 1 equals 2. That makes no sense. But you would more call these literals. Or something like A, or apple, or 2.5. But what if we want to make pi be a constant, but not pi as in the string pi, but pi as in the number pi. So 3.14, some atrocious number. Isn't it like 157, something like that? This is the most numbers I know of that, I think. That's probably not even right. Okay. And how do we do that? So we're going to use a keyword. Remember that word keyword from before? It was like, whoa, way back a week or 2 ago. Maybe like 2 weeks ago. Whoa. No, 1 week ago. But we're going to use a keyword called const. And then our data type, our identifier, the assignment operator. We're out of room. And then a value to assign it to. So in the case of pi, which is equal to 3.14, we'll just say for now, we could say const. I write it in red because the text editor I use colors it red. And then float pi equals 3.14. And then later on in my program, if I say pi equals 3.14159, which I think is right. Let's fact check real quick. 3.14159. Okay, cool. This will be a compiler error. It's not a semantics error. That is a syntax error because you are trying to override a const, which is syntactically incorrect. So how can these things help us out? Because, well, say for us, when we're testing our program, we're like, okay, cool. This is good enough for us. And we have like a million computations down here of like, I don't know, like double A1 equals X plus Y times pi 3 divided by Y. And then like some other like double A2 equals pi times 7 divided by 3 modulus 2. None of this matters that I'm writing. I'm just writing crap out of my head. And then just a bunch of equations that keep on using pi over and over again. Well, say for us, 3.14 is cool. But then the scientist that we're making our program for needs to come in and say, all right, this is not good enough for me. I need this to be more accurate, like 3.14159. Look how easy it is to edit it. Instead of having to go down here and say, okay, well, before this was 3.14, and now I need to add a 159, and this was 3.14, now I need to add a 159, and then so on and so forth. It's so much easier just to edit it the one time right here. Or say, like, you need it even more precise to, like, let's get even more digits of pi. Any digits pi. So let's say like 3.14159 159. Where'd it go? 265,265,358,9,7 into the nether. Okay, well now we need to change that into a double. Well, look how easy that was to edit that computation. Instead of having to, well, I guess, if you did hard code this number in there, the double wouldn't matter. But like, because it is that, but like, you see, you get my point. You don't have to keep coming down here and editing a million times the same value over and over. You can just edit it this one time right here and call it a day. Let's go into a good example of that. That will hopefully illustrate this a little bit. Say you want a program that could be like, you know, every day you're going to output, leading up to a game, you're going to output who's going to win and what they're favored to win at. So say we have like today Vegas. That's not how you spell Vegas. Vegas is favored to win at like a 57%. And then Reno is favored to win at a 43%. And you just need your program today to output this data that you're entering in. So you could, very simply just say, cout Vegas is favored to win at 57%. Reno is unfavored to lose at 43%. But what about tomorrow when this data changes to like 60%, 40%? Or like, what if it even further, which you would hate to see happen, but unfortunately it does happen, it goes to like 45%, 55%. Then you need to change both this number, and you need to put Vegas there and Reno here. So you would have to come down here and edit all this stuff in your strings, and maybe if you had a bunch of more computations down here where you're using these values and outputting these values, then you're going to have to go edit them all down here. Or you could have just very easily started out and said const string favored equals Vegas, const string unfavored equals Reno, const int percent. Well, we'll just say percent 1 equals, what was it, 57? Const int percent 2 equals 43. And then you can just see out favored will, what did we say? Favored is favored to win at percent 1%. See out unfavored is unfavored to win at percent 2% new line. Sorry, I'm running out of space there, but hopefully you guys understand what's going on over there. Or I'll just do that, and then you can see. So then tomorrow, and then you could have, all that extra code down there that who knows what it would be. But tomorrow, if they unfortunately switch to this, we could easily come down and change this to Reno and this to Vegas, this to, what was it, 55, and then this to 45. And then it will change everything output down here without having to go in and keep editing the strings and editing all the stuff down here. And it just makes your life a lot easier.